stuff to do, and then can be done. Sound good? You with me for that long? All right. So we're going to pick up kind of where we had left off with 15.5, talking about financial mathematics. This will be the end of chapter 15 today. So up to this point in chapter 15, we had talked about simple interest. We've talked about compound interest. And today we're going to start by talking about continuously compounding interest. So if I say interest is compounded continuously, how many times a year does that interest compound? If I say interest is compounded continuously for 1 year, how many times does that happen in 1 year? More than that. More than that. More than that. What do you mean forever?
It goes on.
Like a number.
Infinity.
Infinity! Yeah, that's what compounding continuously means, is that every instant you're earning some little fraction of that yearly interest. In general, when things are happening continuously, the exponent base is going to be e. I'm going to skip the derivation as to like why that's happening. But that's the key here. So our continuously compounded interest formula, FV is equal to PV times e to the Rn over 100. The R is still that interest rate as a percentage. N is just the number of years. PV is still present value. FV still future value. All that jazz remains the same. All right, let's do some examples.
Is the Rn like an exponent?
Yes. Yes, that is an exponent. Rn over 100. That is the exponent for E. Our example says Jack invests $800 into savings account with a 5% annual interest rate compounded continuously. How long will it take for Jack to have $500 in interest? Okay, what type of problem is this? Simple interest, compound interest, continuously compounded interest. How did you know? Yeah. So we know it's this formula. All right, so let's start figuring out what goes where. The $800, what's that? Excellent, present value. What's the 5% annual interest rate? The R, good. How long will it take? What's the N? That's what we're solving for. What's the 500? So we're going to have less than we started with. What is that $500? It says $500 in interest, right? What is the future value then?
300.
Not 300.
Them added.
Yeah, 800 plus 500, or $1,300. So far, so good? All right, let's plug it into the formula. So I have 1,300 equals 800 e to the 5n over 100. How are we going to solve this for n? We want to solve that equation for n. Well, in general, what are we going to do? We're going to graph both sides of the equation and find the intersection. Could you also solve this using logarithms? Absolutely. Do you have to do it that way? No, man. And as most of you guys are probably planning on taking an ACT this summer, fall, in general, anytime you run into a solving problem on a standardized test where nobody cares what your work looks like, how would Mr. Kulik solve it? Graph both sides and find the intersection. I'm not going to take any risks on a standardized test of like making some silly arithmetic mistake. I'm just going to graph both sides and find the intersection. Of the 60 or so questions on an ACT, How many of them are probably going to sound like solve for blah? I'd guess like 15 or something, like 25% of them are probably just like solve for x, here's your equation, right? Sound about right? Those of you taken ACT before? A lot of solve for x problems. If you're unsure what to do or just want to be cautious, just do it by graphing, man. Like we're going to do right now. All right, so I typed in one side of the equation to y1, the other side into y2. I'm now going to set my window because the hardest part here is making sure that we have a sensible window. So the x in our equation is this value n for the number of years. What would be the minimum number of years we could possibly deal with? So I'm picking out my x min, which is like the minimum number of years. In any kind of problem, what's the minimum number of years? 0, right? Yeah, you can't have negative time. So we'll do that. Any idea on how long this is going to take? Be like 1 year, 2 years, 10 years, 20 years? Just a guess. Right? Somebody give me a shot at a guess. Probably at least 10 years, right? You've invested stuff in the bank. It's not like the money's growing spectacularly fast. Now, what I always do is whatever my guess is, I usually go just double it. So I'm going to do 0 to 20. Because again, all I really need is the intersection to be on my screen. It doesn't have to look pretty. I'd rather have too much than too little and have it squished than have to go back in and pick a new window and make it a little wider. The Y's are representing my monies. What's the least amount of money this bank account's ever going to be worth? That's going to be my Y min. What do you start with?
500.
You mean 800? Yeah, that'll be the least, right? Whatever I started, invested, it's never going to go down. If I put my money in the bank and don't touch it, should always be more there than when I started, right? The Y max needs to be bigger than what number? What number does Y max have to be bigger than? What number are we trying to get to? 1,300. Has to be bigger than that. Doesn't matter how much bigger. I'm going to just pick 2,000 because it's like a nice round number. And then I'm going to hit graph. So there's my 1,300 line. Here's my account value curve. Woo, look at that. There's my intersection. Second trace, intersect command, enter, enter, enter. So 9.71 years. Does everybody feel okay with this? We can ask the same kind of problems we would about, regular compound interest with continuously compounded interest. It's just they're the same. You're just using a different formula, right? It's not too big of a deal. Here is an interesting question. It says, you find an account that has 6.5% annual interest compounded monthly. What would the equivalent interest be for an account that is compounded annually? Oops. Actually, I'm going to do that. So there's my one account. And then my second account is kind of the same thing, just We don't know R, and we know that K is 1, right? If I compare the equations, notice that those parts are identical, right? That I've highlighted in yellow. So if these two are equivalent equations, this part needs to equal that part, right? Is everybody okay with how I got to this equation? How am I going to solve for R? What's one way I could do it? Could graph both onto the calculator and find the intersection. But this is really not too big of a deal because that exponent of 1, does that really matter? So does parenthesis really need to be there? Not really. So I can just subtract 1 from both sides and then multiply by 100, right? Is that okay? You see what I did there? Again, you could graph both sides still. That's okay. I'm just going to do that one by hand, though, because the algebra was pretty easy because there was no logarithm necessary. Although I do have a lot of parentheses going on, which I don't love, but I guess is fine. So I got, what, about 6.70% interest. Is everybody okay with what I did there? Why would I be interested in doing something like this? It allows me to compare two different investment opportunities to see which one is really the better one, right? If I take something at some percent interest compounded monthly and something at some different percent interest compounded daily, how do I know which one is actually better? Right? So if you go loan shopping or go investment shopping, oftentimes what you'll be presented with is your interest rate as an APY, which is just what is the equivalent annual interest rate. So if it's just compounded yearly, what is the equivalent interest rate? So even though your loan might be compounded monthly at some different percent interest, what they'll probably report to you is an APY and say, oh, this is a 6.7 APY interest rate on this loan, even though the terms are actually a little bit different than that. The reason they do that is so that you can easily compare one loan to another. And this is part of like consumer rights. Like I think it's a law in the United States that all these loans have to report out things as APYs to try to make it easier on you as the customer as to what's really the better deal. You know what I'm saying? Rather than giving you like advertise a lower interest rate with some weird compounding going on that's actually worse than, kind of the market. But it looks better, but we've like hidden it a little bit. You know what I'm saying? It's trying to make it so that you can't get shystered out of your money. Is everybody okay with that, with this idea? So our conversion to APY, look at what it is. Look at this formula and look at what we did. What do you notice? It's the same, right? Oh, we just did an example of this, didn't we? You betcha we did. All right. So let's do another one. Very common situation says, which savings account is the better investment? One that pays 7.8% compounded quarterly, or one that pays 7.65% compounded weekly? So, because these are investments, are we going to want the bigger interest or the smaller interest rate for putting these into a savings account? Do we want the bigger interest rate or the smaller one? Which one would be better for us as the consumer? Come on, guys, that's not a hard question. Talk about a savings account for you. Do you want the bigger interest rate or the smaller? Bigger, right? If you're borrowing money, which one do you want? Smaller. It's not that hard. You can do it. All right. So let's see. So my R1 is 7.8 and my K1 is 4. My R2 is 6.5 and my R2 is 52. So now it's just a case of plugging it in, right? So the first one is 803. And the second one, I'm just going to update the first one. And then 794. So that first situation is better because the interest rate is a little bit higher. And I'm a savvy investor. I want all the monies. If you're offering me more money, I'm not going to walk past. I'm going to bend over, pick that money up. You know what I'm saying? Everybody feel good so far? No big deal, right? We're just basically plugging stuff into a formula, right? Trying to give you a little bit more context of why someone would want to do this, but all right, let's take a look at some annuities. So an annuity is an account in which a sequence of payments are made. An ordinary annuity is an annuity where you make the same deposit at the end of every period that the interest is calculated on that account. The future value of the annuity account are consisting of N ordinary payments of PMT dollars at an interest rate per compounding period of I is formula yada yada yada, where I is equal to R over 100K and N is equal to K times N. So like, what the heck is this talking about? So what's the first thing that you're going to do once you get a new job? Like a real job, like a career job? Huh? Well, I mean, yes, but like with your money. What are you gonna do with first thing you do with your money when you get a real job?
Buy a house, save.
Retirement savings account. Most people, when they're saving for retirement, will save like a fixed amount of money every single year. Ostensibly, this is an annuity, right? You're going to save, $100 out of every paycheck or $500 a month or whatever works for you, but some kind of an annuity, right? That's basically what we're going with, or the idea is here. There's also like other types of annuities where, like if you win the lottery, there's like two options, right, on how you claim your money, right? You can take a lump sum, like give me some percentage of the jackpot all at once, or I can take an annuity where it's going to pay me like a fixed amount of money for the next 30 years, like every month or whatever, right? Does that sound, you guys get it? Like you've heard about this thing before? Sometimes when you get real old to retirement age and you own your own home, you can do like something called a reverse mortgage, where you can sell the bank your house, but the bank doesn't buy it all at once. It pays you in like monthly installments, and you can continue living in your house until like the bank owns it, and then in which case you have to move. And sometimes that's a good deal for a retired person, where it's like I can have a 10-year annuity and have some additional income, and then at the end of this 10 years we're ready to move into a senior living center or something, and who knows. All right, so let's look at some examples. At the end of each quarter, Sarah makes a $500 payment into an annuity account. If her investment earns 7.88% annual interest compounded quarterly, what will the value of Sarah's annuity be in 20 years? What word in here tells me what we're doing? Tells me which formula I'm going to use. What word in here tells me that? Annuity, right? That tells me we need to use this formula. Okay, $500 is what in the formula? Yep, that's the payment, PMT. 7.88% is it's R. Keep in mind that I is equal to R over K. So we need to calculate, we'll have to calculate I separately. Compounded quarterly, that tells me K is 4. What will the value be after 20 years? That's N. And the future value is what we're looking for, right? Does everybody feel okay there? So we'll start by calculating I. And cap N. So I have that. Instead of writing all the stuff in for I, I'm just going to do that. Is everybody okay there? So on my calculator, I'm going to start by calculating I. Yes, of course. Now, instead of copying that number every time I see I, I'm going to press second and the negative sign, and that's just going to give me the ANS command, which is just going to copy the last value that my calculator output in the spot. It's just a little bit easier than having to copy that number in. Is everybody okay with how I typed that in there? Sometimes that's the hardest thing, is to get your calculator to do what you're asking it to do. So it looks like we have $95,483.39. Why did I round to 2 decimal places? Because it's money, right? We write monies in dollars and cents. That's why I round to 2 decimal places. Gosh, guys. Okay. Last idea. So the other type of financial decision most people end up having to do is take out loans, whether it's to buy a house or a car or, like pay for your college education or whatever that may be. The net or total amount of money borrowed for a loan is called the present value or principal value. The PV of a loan consisting of n equal payments of PMT dollars at an interest rate per compounding period of I is equal to PV equals PMT times 1 minus 1 plus I to the negative n over I, where I is R over 100K and n is equal to Kn. Looks pretty similar to the previous formula, right? Except what's happening here, instead of every month, like we're gaining money, what's happening every month now? It's like losing money, right? Because it's like how much you owe, the amount you owe is going down. Everybody's okay with that? Or you can think about like you starting with a big negative balance and you're paying that to zero. So like you're putting money in, but it's going to zero. All right. Let's look at an example. Maria buys a new car for $18,500. What are the monthly payments for a 4-year loan if she makes a $2,000 down payment, an annual interest rate of 2.9%? What word in this tells us what formula to use? What word in this problem tells us the formula that we're going to be using? Nope. Close. Nope. Loan, right? So we need the equation for a loan. Is this helpful in like at least talking about like what word is the key to telling us what formula is going to use? I hope so. All right. All right, so let's see. This is R, right? We're solving for monthly payments. The monthly is telling us K is 12. 4-year is telling us that N is 4. What is the present value, though? I see $2 amounts. Or the principal value. It says the car cost $18,500 and we make a $2,000 down payment. So how much money do we actually borrow? Nope. Yeah, 16,500. Right? So when we say a down payment, what that means is you walked into the car dealership with $2,000 check or something. You gave that them up front, and then you had to borrow the remaining $16,500. Everybody's okay with how we came up with that? Oops. Got to calculate I. It's a pretty good interest rate there that she's getting. Okay. So to solve this, let's do this by graphing because the algebra is going to be Well, I guess not terrible, but kind of sucky. Ooh, look what I forgot to do. What are we going to put in for I? We didn't do that yet, right? So let's do that real quick. Watch this. So I go back to the home screen. So that's my value for I. Now I could copy that in, or I could have the calculator remember that number for me and then recall it when I graph it. That's what I want to do because I don't want to have to copy this down and type that number in a bunch of times. Particularly that number could be really long, have a lot of decimal places. So what I'm going to do is I'm going to press the STO button right here above the on. Makes the little arrow. And I'm going to store that into the letter I. I'm going to press enter. So now whenever I call that letter I, the calculator is going to remember that I means that number. So I'll go back into my y equals here and finish this equation out, but this time I'm going to put the i's in it. All right. So I'm going to go to set my window. The x value in my equation was the payment for a car. So again, it has to be at least 0, right? What's a good upper bound in dollar amounts for a car payment? Anybody with a guess here? It's a $16,000 car-ish. We're paying it off over the course of 4 years. Anybody with an idea of what a reasonable car payment might be? Aim high. We always want to overshoot. $20,000 per month.
Oh, I didn't know per month.
Yeah, the monthly car payment.
2,000?
Yeah, probably like, yeah, 500-600 is probably a good upper bound on what a car payment might be.
Oh.
Well, again, like real quick math, $2,000 a month is going to be $24,000 in the first year, right? So like little overshot there, but that's okay. Like again, the only way we can build intuition, the only way to build intuition is to like make guesses and then have somebody point out to you like, oh, that was not a great guess, and why wasn't it a great guess? And like, it's how we build intuition, right? You don't know. You've never bought a car before, probably. You don't have a car payment.
I have a car loan, actually.
In your name or in your
Might
parents'
be.
name?
Yeah.
It's probably in your parents' name. I don't think you'd get approved with no income. You know what I mean? Now, a college loan you might be able to get in your own name. All right. Continuing on, the minimum value. Well, I don't really care. I just need it to wrap around 16,500. So maybe let's do 15,000 and then 20,000. As long as it covers that, I'm pretty good, right? Oops, that's too many thousands. So there's that. Here comes my curve. Unless I screwed up the formula. Oh, no, there it is. Ooh, right at the edge. Second trace, intersect command, enter, enter, enter. $4,808.25 or 26 cents. That's not the answer I got in the back of the book. Did I screw something up? Sure did. Look at what I did here, folks. What a dumb Magoo I am. Y divided by 100 times 4 should have been 100 times 12. Mr. Kulik. Way to booger that one up on us. You know what, guys? I'm sorry. Okay, try it again. Notice that because all I did was screw up the I, if I just restore the I, nothing I had to change in my Y equals menu, which is super cool. And there we go, 364.49. So $364.49 a month for your car note, which is, like whatever. Using the same information from example 39 and assuming that all of Maria's payments are equal, how much in interest does Maria pay over the life of the loan? So, how many loan payments is Maria going to make? How many times is she going to pay for that car? How many times that car bill come?
12 times 4.
Okay, 12 times 4. And then how much is she paying each time?
364.
Yep. So that'll be how much she ends up paying the bank, right? So let's do that. So $17,495.52. Okay, so that's how much she ended up paying the bank. How much of that is interest? Right? How much did she borrow from the bank? So anything extra that she paid must have been the interest. So $995.52. It's almost $1,000 in interest. If you can pay cash up front, it's a big savings. But who has like $16,000 laying around in cash? Not many people. Or who can go without a car for 4 years to save up $16,000 in cash? Not many people. What?
Grandma never even had a license.
Did she drive anyways?
No, we're just never
Okay. Some people just say, forget it, I'm just doing it anyways.
I don't have my license.
What? Get a license.
I know.
Okay.
I'm close.
All right. I need to show you something on your calculator. Yes.
Okay, yeah.
Do you want to miss this?
Is this gonna take long?
No.
Okay, I'll stay.
Take out your calculator.
It's so annoying.
Your calculator has a built-in function that can do all these problems without having to do any math at all if you know how to use it. Ooh, you had me at built-in function on my calculator. All right. So let's redo this example 39 here. So we're going to press the apps button. That's the one with the purple word right kind of by the green alpha button. Guess which option we're going to pick? Yeah, there's only one, picking finance. And we're going to pick the TVM solver. So for our problem, N is the number of loan payments we have to make. That was the 12 times 4, or 48. The percent I is the interest. So that was the 12.9%. The present value is what we borrow from the bank. Because this is a loan, the future value should be 0. The payments per year, well, we do 12 of those, right? And the compounds per year, that happens 12 also, because those are always the same for a loan. We're always going to make our payments at the end of the month. And if I set that up and we're looking to solve for payment, I press alpha and enter, and blah, spits out the number.
Let's say you have $16,000 in cash. Would it be better to pay cash or
I would say depending on the interest rate, you might be better off investing your money, but 2.9% is a pretty staggeringly low interest rate. No. N is the number of payments.
It's like a normal.
Right now, it's probably 5 or 6 on a new car. If it's a used car, it's probably closer to 10. That's pretty high, though. Interest rates are quite high right now. If it was a year ago or 2 years ago.
So you don't have to calculate high.
No. This is just like the percent interest rate.
But you have to calculate that.
So so you move your cursor to payment, right? Avery, your cursor's right here. And if you press alpha and enter, it does the computation. Did it work?
Yeah.
Okay. And this will work for like any of these kinds of problems, right? Let's go to 39, or I'm sorry, example 38. We're making $500 payment. So I go to payment. That's going to be 500, and I'm going to make that negative 500. Listen, please, so you know how to use this thing because it's a nice tool to use. I'm going to make that negative 500 because the way I'm thinking about this is I'm taking $500 of my money and putting it somewhere else. So it's like negative coming out of my pocket. It's going into this bank account or whatever. Is everybody okay with that? The present value is 0. I'm going to have 0 monies in there right now at the start. My interest rate is 7.88. The N, well, we're compounding quarterly, so we're making 4 payments for 20 years. So 4 times 20. The payments per year, we're having 4 of those, and it says it's compounding 4 times per year. So I'm going to now move my cursor on future value and press alpha enter. And look at what I got. Is that the same number we got down here?
Yeah.
Yeah. Was that quicker than doing graphing and finding the intersection, having to muck around with windows and stuff? Yeah. Yeah, this is a pretty cool tool, right?
Wait, why'd you put 4 and 4?
Because it tells us it's compounded quarterly, and we're making payments each quarter. So payments per year is 4, compounds per year is 4. So it should be just the K in these cases. Is that cool? What do you?
How do we find N again? Which 2 did you take?
It's always the years times the K. At this point, we can, we're finished up. You guys should be able to do the rest of the homework. So 147 through 184.
Why are you weird? Ew.
It's like you can't help it. People are weird when they're weird. Like it's asking like
stalkerishly weird.
it's like, why are you Avery? I'm Avery because I'm Avery. You know? So I'm done at this point. Everybody happy? I mean, probably not really, but next class, review day, half sheet.
The next class after that.
Correct, which would be Monday.
Oh, next week? Mr. Cooper, wait, what? Wait,
Oh no, wait a minute.
It'd be today, Tuesday.
Today is Tuesday.
It'd be Wednesday? No, it's Monday.
Hold on though.
Oh, we don't have school on Monday. Yeah, we do. Wait, yes.
No, we do. Hold on a second.
We don't have school that Friday.
Hold on a second. You guys are all like, "Rah, rah, 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 rah."
Next.
You're yapping.
Yeah, next Friday.
I miss.
No.
Just shh. Let me get this out.
Okay,
Good golly, Miss Molly. All right, so the second period class would be taking this test on Friday. I think that overlapped with an AP exam. So they requested to do it on Tuesday. I would grant you guys the same option. If Monday versus Wednesday, would we rather do Wednesday?
Yes.
Let's do that then.
Wait, we do have school next Friday.
Yes.
We don't have school like next.
Next.
Okay, everybody's happy with that? Okay.
Not this, like, this Monday, we have school, but like